Good day, guys. This is Mr. Prince Maths and Science class, and in this video I'm going to be talking about permutation and combination. And what we need to know is that permutation and combination both deal with counting numbers of possible selection from a different set of objects or from a different collection of people or numbers. Okay, and one thing we need to know is that in permutation the order matters. And scenarios in which we use permutation formula is, for example, like when we get a question where you are asked to arrange people in a seat, or you are trying to set password, or in a race competition. For example, when you are trying to set password, the order in which you set the password matters, because if you switch the order, the password will be different. And in a race competition, let's say they are given a race competition for first, second, third position. That's like gold, bronze, medal. The order matters, okay? And for combination, the order does not matter, okay? And for example, scenarios in which you use combination is when choosing a committee or a team or like lottery numbers, right? And you can see on top, we have n factorial. So I'm going to explain that right here, n factorial. So n factorial, we can see I wrote n times n minus 1 times n minus 2. So whatever number it is, you keep decreasing it and multiplying it with the lesser number that is in the same order. So for example, I will do 5 factorial. So for 5 factorial, that will be 5 times 4 times 3 times 2 times 1. So you keep reducing the number you multiply it with in a sequential order till you get to 1. Or let's say 3 factorial. You can do it as 3 times 2 times 1. And in most of the examples I'm going to be doing, whenever I have the same factorial on top and below, I'm just going to cross it out instead of writing out everything in full, because it's still going to yield the same result. So the first example I have here is 7 permutation 4. 7 permutation 4. So that's equals to 7 factorial over 7 minus 4 factorial. Okay, so that we have 7 factorial divided by 3 factorial. Okay, so that will be 7 times 6 times 5 times 4 times, I'll write it up to 3 factorial, because if I write it up to 1, it's still going to be the same with the denominator, which is 3 factorial. So this 3 factorial will cross out 3 factorial. So we have 7 times 6 is 42, 5 times 4 is 20. So we have 42 times 20. Let me just point that in the calculator. So 42 times 20, I believe that should be 840. 840. Okay. So this one we have 7 combination 4. So that's 7 factorial over 7 minus 4 factorial times 4 factorial. So I have 7 factorial over 3 factorial times 4 factorial, okay? So that's, I'm going to write it up to 4, okay? So that's 7 times 6 times 5 times 4 factorial over 4 factorial times 3 times 2 times 1, okay? So this 4 factorial will cross out 4 factorial. So 3 times 2 is 6, which cross out 6 on top. So we have 7 times 5. So that will be equals to 35. Okay. So that's it for now. We have number 3. Number 3 says, how many different ways can the letters of each word be arranged? Now I want to do an example where we are given a letter word, and then we are asked to find how many different ways these words can be arranged. Now, for example, for the one for Amanda, we'll count how many letter words are in Amanda. So we have A, M, A, N, D, A. So that's 1, 2, 3, 4, 5, 6. Okay, so that will be 6 factorial. And then we are going to divide it by the letters that are repeated. So the letters that are repeated will be at the denominator. So now, for example, the letter that one letter that I repeated is A. So how many times was A repeated? 1, 2, 3. So that's 3 factorial. And then M is only once. n is 1, d is 1. So we have 6 factorial divided by 3 factorial. So that will be 6 times 5 times 4 times 3 factorial divided by 3 factorial. Okay, so 3 factorial will cross out 3 factorial. So we have 6 times 5 is 30, and 30 times 4. 30 times 4 is equals to 120. So it's 120 ways that the letters in Amanda can be arranged. So now we have football now. So how many letter words is football? 1, 2, 3, 4, 5, 6, 7, 8. So we are football is an 8-letter word. Okay, and now we're going to count the letters that were repeated. O was repeated twice, so that will be 2 factorial. And then F and T was once, B once, A once, L is twice, divided by another 2 factorial. Okay, so we can write it as A times 7 times 6 times 5 times 4 times 3. Sorry, let me write it underneath. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial times 2 times 1. So 2 factorial will cross out 2 factorial. 2 times 1, that's 2. 4 divided by 2 will give us 2. Okay, so we have 8 times 7, 56. So 6 times 5 is 30. 30 times 2 is 60. So we have 56 times 60. So I'm going to punch that in the calculator. So 56 times 60 is 3,360 ways. Okay, so the letters in the word football can be arranged in 3,360 ways. So number 4, we have, in how many ways can 5 people sit at a circular table? So now this, we have to find the number of arrangements in a circular pattern. Okay, and the formula that we use is number of arrangements. So the formula is n minus 1 factorial divided by 2. So this is the formula whenever you are given a scenario question that is in a circular pattern. So we have 5 people sitting, so n will be 5. So that will be 5 minus 1 factorial divided by 2. Okay, so that will be 4 factorial divided by 2. So that will be 4 times 3 times 2 times 1 divided by 2. So 2 we cross out 2. So 4 times 3 is 6. 4 times 3 is 12. So the 12 ways that 5 people can sit at a circular table. So now number 5. It says, in how many ways can 4 charms be placed on a necklace that does not have a clasp? A necklace is also circular in pattern, right? So the formula will still be n minus 1 factorial divided by 2. Okay, so now n is 4. So we have 4 minus 1 factorial divided by 2. So that will be 3 factorial divided by 2. So that will be 3 times 2 times 1 over 2. So 2 will cross out 2. So it's going to be 3 ways that 4 charms can be placed on a necklace that does not have a clasp. Okay. Now I'm going to do one more question. This one also is permutation. It says, in how many ways can you arrange 2 of the letters in the word math? M-A-T-H. So now I want to make out a scenario where we can all understand what is going on. So when I write out the word M-A-T-H, now we are going to be picking 2 words out of all the 4 letters. We are going to be picking 2 letters out of all the 4 letters in the word math and be combining them in different ways. So now let me take M-A, okay? And if I switch it, I can also write it as A-M. And then I can take T-H. If I switch it, that will be H-T, okay? And then I can pick M-T. If I write it at the in the reverse order, it will be TM. Okay, and then if I write MH, write it in the reverse order is HM. If I write AT, TA. Okay. AH, HA. Okay. So we can see that every two letter word that was written side by side each other, the two of each of them, like all the ones on the left hand side and right hand side, they all contain the same type of letters, but in a reverse order. Okay. So now in this case the order matters, because as we're trying to arrange the two letter words side by side, this pair of two letter words is different from this two pair, even though they have the same type of letter, but because the order in the way they are written, matters. And that's why we have 12 different ways. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So because the order matters, we can write it in 12 different ways. Or we can just say, math is a 4-letter word. We can just say 4 permutation 2. So that'll be 4 factorial divided by 4 minus 2 factorial. So that'll be 4 factorial divided by 2 factorial. Okay. So that'll be 4 times 3 times 2 times 1 over 2 times 1. This will cross out each other. So that is equal to 12 ways. So that's it for this video. I'm going to continue with more examples in the next video. I'm going to have another video, permutation part 2. And I hope you enjoyed this video. Make sure you share the video. Make sure you comment. Make sure you subscribe to this channel. Okay? And thank you for watching. I appreciate you. Peace out.